Hi everyone, thanks for coming to the Code.org workshop and to TeachTech. I'm Shu and I'm a sophomore studying computer science.
I'm Amanda. I'm also a sophomore studying computer science.
And today we're going to talk about Code.org. So Code.org, as you guys heard about a little bit in the previous talks, is essentially a website designed for beginners and also for professionals who may just be beginning to teach computer science to their students. And Code.org is a website, sort of a repository of a lot of different activities, worksheets, online puzzles that you can give to your students, and it's really enjoyable because it's essentially a lot of different games. And you might have heard about Code.org. Someone mentioned about an hour of code. An hour of code is essentially something that Code.org has every year. For 60 minutes, teachers allow their students to go on the website and complete various activities. And it's really a great introduction to computer science because they're very simple, but also super entertaining. And so just an overview of what this workshop will entail. I'll tell you a little bit more about Code.org, who Code.org caters to, so the different levels and the different students and with various backgrounds. Amanda will talk about the sample curriculum. We'll provide more details and resources, and we'll also show you what Code.org looks like. So what is Code.org? Code.org has a mission of especially targeting underrepresented minorities, females, but they also have various activities that make it very accessible to students of all ages and from various backgrounds. And here are just some statistics about Code.org. 25% of the students in the US have accounts on Code.org, and I'm one of them. I started coding in high school, or I started computer science in high school, which is very basics. And I was one of the students who did an hour of code in high school. It was really fun. That's how I got into it, and now I'm majoring in it. So I thought that was really cool. 10 million of our students are female, and as a female student, I totally support that, and I'm so happy about that statistic. 700,000 teachers in America and probably worldwide use Code.org. 10% of the world's students have heard and tried out the hour of code, and 20 states have changed their policy to support and include computer science in their school curriculum. Next slide. So, statistics aside, Code.org is a block programming website. And what block programming is essentially you have your code in blocks, sort of like puzzle pieces, and you fit them together to create a puzzle or a complete puzzle. And that puzzle includes different logic, it includes different variables, and it differs based on how you put the blocks together, which blocks you put to the screen, and it's so cool because given just maybe like 5 blocks, you can create so many different programs from there. And block programming is really awesome, especially for beginners, because you don't have to worry about the syntax of coding. I feel like the syntax of coding can really deter students from continuing with computer science, especially at the beginning and if they're at a very young age, because it can get really frustrating if you're missing a colon or a closing parentheses. Like, debugging can be very frustrating, but with block programming, it sort of abstracts away from the very minor details of the syntax, and you only have to worry about the logic. And logic is very important in computer science, and I have to argue that maybe logic is even more important just than the language itself. Sorry. It also, like I said, it has a lot of cool challenges and puzzles, and these challenges and puzzles are really entertaining because they feature cartoon characters that the kids would recognize, like Angry Birds or like Plants and Zombies. So I think they essentially sort of like think of them as games and not really as computer science, but they're actually learning a lot from them. And it introduces fundamental computer science concepts. Like I mentioned earlier, I think it really touches on logic more than the syntax, which is great for beginners. And so this is just a chart of who Code.org caters to. So you have elementary, middle, high school. It touches on all the different levels. And as you can see, there are various sort of curriculums that are tailored to different school levels. You have CS Fundamentals for younger kids, elementary school students. You have CS Discoveries for middle and high school students. And the CS Principles for high school students that touches more on like the AP/CS side of concepts. And if you look at the bottom, there's professional learning for all grade levels. So resources for teachers are available for any grade. And this is just like a snapshot of what the courses are that are available for elementary school students. So down here you can see for A and B, they divide it between 4 to 7 and 5 to 8, ages between 5 and 8. And A is for pre-readers and B is for post-readers. So you can see that it's very tailored even within each school level. And then I think the next slide also offers more courses for elementary school students. So if you look at D, they go over algorithms, nested loops, conditionals, and it's tailored for ages 7 to 11. What's really cool is that I was learning those concepts in my introduction to computer science class. So they're learning very, very complex things, but in a very entertaining way too. And if you look at F, it says that there are sort of curriculum available for creating your own art, your story, or games. So I think that's really exciting for kids who might be more on the creative side. Once they've mastered the basics, they might want to create their own projects.
Hi, yeah, so now I'll be talking about how Coding Amen has used Code.org in our curriculum. And so we used Code.org primarily last fall in our pilot year with David's class and another class from Fairhaven. And yeah, so we started out with Code.org because it was very simple and it already has a lot of curriculum built into it. And this is how the general structure of our classes went. We would first introduce a fundamental CS concept. So for example, like what you saw, what Omi presented, we would introduce what is a loop? And we would give the students the definition. Oh, a loop is the action of doing something over and over again. And once we give this definition to students, we would ask them questions like, oh, so what do you think is a loop in real life? What do you do in real life that you think is a loop? And then they would give answers like, oh, brushing my teeth is a loop. Oh, waking up every day is a loop, which is correct. So once we've introduced them to the very basic definition of a loop, we will, then we'll do an unplugged activity. So this is something that you guys have just experienced just now in the classroom, where we did things like present wrapping and dancing. Unplugged activities are really great because it helps reinforce the concept, and students get to actually experience what it is. And an example of an unplugged activity that we use is something called the maze activity. And we especially like this one because you'll see later on that it's very similar to what Code.org does, the layout of Code.org, where it's very path-wise. You'll see that there are avatars that travel through paths. So this is something that we use to let students get used to Code.org, where so you have I want to travel from the green square to the purple square, and you have these three actions: move forward, turn left, turn right, and we would let the students tell us, oh, how should I get from the green square to the purple square.
Oh, and we also noted the last bullet point says how can you use loops to make our code more efficient. So we also have challenge questions that force the students to really sort of understand the computer science concepts, because for example you can use a loop where you move 3 spaces up and then you turn left, and if you use that loop it's going to happen again because you're gonna and then step 1 forward, because then it's gonna, as you can see, it's a repetition of the same steps, and that's what computer science is really about, making a very complex process very simple with an algorithm.
So this is actually the first unplugged activity that we do in all our Coding classes, and it's called the Robot Challenge, where we have one of our mentors, so one of our Yale students, be a robot, and the students get to control this robot to fulfill an objective. So for example, if I'm the robot and my objective is to pick up that marker pen, right, and using the 3 movements that not 3, 5, all these 5 actions, we want students to tell us, how do you get the robot from here to pick up the pen, right? And so this gets students really involved, and they'll it's better because they will be able to spatially realize what's going on when it comes to Code.org.
Yeah.
So this is an example of what it really looks like when you go onto Code.org. This is an example of a challenge. And as you can see, it's a plants versus zombies kind of setup. And how you, it's the previous maze activity, you can see it's a path that the zombie has to take from here to reach the side. so once we've conducted our untitled activity, then we move on to give the students specific puzzles on code.org that that include the fundamentals that we just taught. So I think now we're going to try out a few puzzles in code.org itself. So if you guys have laptops that you want to open up.
Or we could just like do it on the screen of you, and you can like visit the website later. So here's one of the activities that code.org has, and essentially what you want to do is you want to get the angry bird to eat the pig, right? Yeah. So which blocks should we put in first? And feel free to just shout them out. So you have your 3 blocks: move forward, turn left, or turn right.
It's kind of hard to tell which way the bird's facing.
Yeah, and that's what the students are always confused about. So right now it's...
We just move forward and find out.
Yeah, perfect. Oh, sorry.
That's which way we were facing.
Yep.
So there's 2 important things I want to bring up here. So this is why we feel that the robot activity really helps with this kind of thing. Because one of the cons that I'll talk about of code.org is that the avatars, like the way they face, is a bit arbitrary sometimes, and it's hard for students to realize like which way turn left is and turn right is.
Mm-hmm.
And then another thing I want to bring up is that usually in the beginning, kids find it really useful to just play around with the blocks and see what the actions that it does, and it's kind of like a trial and error in the beginning.
Yeah, and I think like trial and error is really important in CS because we really encourage people to sort of break things and learn through breaking them. And I feel like it's better to do that yourself than to maybe go to office hours and ask your TA, like, how do I do this? Like, by breaking it and learning from your mistakes, it's really reinforced in your head, and you really understand it the next time. And also another common mistake, if you do end up teaching code.org to your students, is that they're going to ask, like, does turn left mean turn left and then take a step? And I think you should encourage them to try it out for yourself. Like, put the turn left button here and just see what happens. But just for time's sake, turn left just doesn't take another step, so it just rotates the bird a different direction. But yeah, so if we want to complete this puzzle, which blocks would we need for our program?
So we know it's not move forward.
Yeah. Yep.
Yeah.
Mhm. And it looks like 1, 2, 3, 4.
It's always adorable to watch kindergartners or high school students like holding up their hands and trying like which way. It's
You'll
actually
be like turning in your seats with the computer.
Oops, 3. And then I would have to turn left and then step forward again. Hopefully that's right. Oh no, wait.
Yeah, you gotta turn again.
Yeah, so this is like Shu's demonstrating an important process called debugging. It's like encountering a problem and trying to figure
Turn
out
right.
like where
Yes.
you went wrong.
one thing that often happens with students here is once there's a mistake, they often will throw out all of their work and start over. And so
Yeah.
you have to kind of teach them, no, look, you can insert a block. You don't have to just throw out your whole solution.
Does it let you run just part of it? Like, can you pull out a chunk? I know you can do that, like in Scratch. You can just pull out a chunk and say, just do this part.
You can also
Yeah.
You can pull it out. It's only going to run the part that's attached to the when run block. So if you close out it,
Yeah. Also, I think one thing really cool to show to your students is that if you click on this show code thing, this is actually all the code that was written from the blocks. So even though it seems like you're just dragging and dropping blocks, you're writing code by doing that. So by doing that, I wrote 8 lines of code. Yeah. And then we can do one more, because this one includes a new block that I think is really important. You have the repeat block, and that translates to sort of like a while loop or any type of loop in CS.
One thing you see in any classroom, but especially here, is many students will try to avoid cognitive load. So they will try to avoid interacting with
Yeah.
the blocker.
Yeah.
So what's nice about code.org is it's very directed. If the student completes the puzzle by putting 5 move forward blocks,
Mm-hmm.
then we'll see what happens. So it runs it.
Mm-hmm. And it's completely right. But as you can see, yeah, if you see up there, there's a speech bubble that says, not quite, you have to use a block you aren't using yet. And they're encouraging you to
the
use.
The instruction right above says you have to use only 2 blocks.
Right.
So that's nice about code.org. If you're using Scratch or App Inventor, it's not going to tell you stylistic things. It's not going to say, hey, there was a better way to do that. It'll just work or not work.
Yeah, and note that here you can actually change the number. So it doesn't have to be 5 every time. Hey, and then you show code. So here you can see it's like a for loop, right? That repeat block translates to a for loop in computer science.
You had to click on show code to see that.
Yeah.
I would love that because we use a lot of Chromebooks in my school, and the kids have all accidentally done the thing where it shows the code behind the website. Yeah, and I have a couple kids who now, like, every time they open up a website, they open that up and they're like trying so hard to figure out, but it's like completely incomprehensible. They would recognize that immediately and be like, oh, it looks like that thing that pops up, right? Like they would recognize that, and they would be able to figure out this piece of code.
Yeah.
Unlike the website, which they're like, oh my god, and they try, like, you can change numbers, right? And it'll like change.
Yeah, on the website.
So that's exciting.
Yep. So that's pretty much code.org. Right now, the exercises I'm doing is do something called Accelerated Intro to CS course, and if, like, say you maybe like do one of them, one lesson a week or multiple lessons a week, I think you will be able to get through them in like maybe a semester.
So one thing that's a little confusing is they've just, over the last 4 years, they've accrued a ton of content on this website. And so oftentimes these same 20 maze puzzles appear as part of like 3 different courses and an hour of code activity, but it's the same puzzles.
Yeah.
But so it depends what you're looking for. The hour of code, if you go through there, will just be one of these lessons, essentially.
And, oh yeah. And something else we did besides lesson 2, we usually started with lesson 2, but we also worked with the artist, and that one's a little bit more complicated, and it'd be great if you like were able to jump into this after you did the basics, because this one requires more math. As you can see, there are a lot more blocks. There's a lot more like mathematical and computational thinking that has. Yeah, it's actually really hard for even like CS majors like us. Yeah, so it does get more complicated, and I think there are very great like cognitive and challenges. Yes.
Yeah, so that was just like a snippet of what usually goes on in the classes, and yeah, so we did.
Oh, sorry.
Yeah, so we did use the accelerated course for our whole curriculum last fall. Yeah, it was all right.
What grade did you use it with?
We used it with 5th grade, so yeah, Dave's class is 5th grade, and yeah.
Well, they were also bilingual students.
Yeah.
So that might be like some students. We started with code.org for 1 or 2 lessons this year, and we noticed like the 6th to 7th graders were able to zoom through them like really quickly, and they might get bored of like doing the same thing. So that's why like introducing the artist might be exciting. But then if they do finish that too, like it'd be great to like maybe expand to Scratch, which is also drag and drop blocks. So it's like essentially the same idea, but you get to have a lot more freedom with what you create, and sort of thinking about like your own final project maybe.
So I'm going to talk about some pros and cons that we discovered while I was in code.org. Obviously, the pros is it's totally free, and they also have a very like built curriculum that like if you had like 0 experience with CS and you just like really want to jump in and get your feet wet, like code.org is a really great way to start. It's very simple. You can just like run through a lot of problems by yourself really quickly, and you'll definitely like get the hang of it. And I think it's like a gamified kind of structure is also like really fun for kids. And if your kids are also like have no experience in CS, code.org is like a really great place to start. The other thing about Coder.org is it offers a bilingual feature, so which is why I think that's one of the reasons why we use it in David's class. You can switch the whole thing, like how you Google Translate a page, you can translate the whole thing to like Spanish, for example, which might be helpful.
They've got like 40 languages.
Yeah.
Yeah, which is also great because like actual computer programming languages aren't very like diverse. Like it's mainly just English. So this is like a good starting place if you needed something bilingual. They also do a really good job of tracking progress. So if you were a teacher, you could create a like classroom account for your students, and you would be able to track their progress, like how many puzzles they've completed, like where they are at in the course itself, which is great.
Yeah, I wanted to show you what the sort of like what it looks like for on like the teacher side. So last year I was in a classroom and I was able to here you can see like all the students' names and all the progress that they've made, which is really great to see like maybe certain students are struggling or figuring out who to pair with who which other student for like pair programming.
What is that? Like, what are the different colored circles again?
So we're like in progress.
Yeah, they're like yeah.
We started it, but they haven't finished it.
Yeah.
You set it up so that they can't go past a certain lesson.
I haven't tried that, but I assume you would be able to.
Yeah, that I'm not sure. It would be
And so there's a clear difference here. You can just your students could just go to code.org and click on one of these activities and just do it without an account. To get all of this, obviously, they need an account and you need to associate them with your classroom to get the teacher features. But still true.
And another thing that they really like to have, like they encourage is pair programming, which is where you pair students up, and one student is the navigator and the other student is the driver. So so this is what we implemented pair programming in David's class, and we found some like pros and cons. You can see it's like but anyway, pair programming was great because it allowed the students to like sometimes become the teachers themselves when they paired. Like one student would get the concept quicker, and then they would like teach the other student. But I think a con that we found was that if we didn't pair students right, they would sometimes just be one student like taking over the whole thing and just doing everything, while the other student just like sat there.
Yeah. So like for pair programming, as Amanda mentioned, you have the driver, which is like the person actually touching the computer and like doing all the code, and then you have the navigator who's like not allowed to touch the computer, but you can give them directions and like tell them where to go. So and it's great to like switch the positions or the rows off, because then certain students can get a lot of practice with coding, while other students can get more practice with sort of like the bigger picture, the more abstract computer science ideas behind the actual activity. Yeah.
And some of the cons that we found while using it was that the pacing of Code.org. So even though we were able to choose like what courses we wanted to use, obviously some students like went through like all the like levels like really quickly, and we had to find things that they could do as well, or like some other students like struggle with more, which I think it's like not like it's not just Code.org, it's like everything in general, but like yeah, you would definitely like want to think of things that could engage other students if they were like a bit ahead of like their peers. Something else is that what Ellis mentioned in the class is that it can be a little bit like abstract, like maybe too abstract when they're teaching like the fundamentals itself. So when they're teaching things like conditionals, which are if and else statements, or like loops, it can be a bit like abstract in the sense that it's I wouldn't say too simple, but
Yeah, like it just like doesn't
basic.
look like the same syntax. Like you saw the repeat block, but that doesn't translate the same thing as like the for loop with like the counter and like the actual syntax. So sometimes it doesn't look the same. And for beginners, like I feel like, speaking from personal experience, like if I didn't know that the repeat block equals the while loop or the for loop, I'm never going to make that connection. And it's not really helpful if that was like the concept that you wanted to learn, right?
So this actually ties into the third point, which is block programming. So block programming is like what you saw, the move forward, turn left, turn right. And it's a great starting point, but eventually you will want to move on to something that, even if it still uses block programming, it's more like creative, so students can like do their own projects. So like, it's a good starting place. Yeah, we already talked about our code. This is something that we use this semester in conjunction with MIT App Inventor, because we feel that it's good to, the students actually are really interested in like exploring. I think our code is more interesting, like mini kind of challenges and like themes. So like there's like a Frozen one and a Moana one, and each of these mini games kind of teach something different. And I think the students are pretty into exploring those things, and we use our code specifically when we like had like free pockets of time, like or when we're in between like holidays and we can't go to class, but the students will just like open it up and like have an hour of code.
Yeah. And this might be a good starting point if you want to try out code.org in your classroom, but not really sure if you like want to commit to all of it. Yeah.
It's an amazing way if you have like an after-school club or some sort of optional activity for students to get them excited about it. Is ask your friends and teachers, hey, can you just do 1 hour in class one day, do the hour of code, and then tell students if they like this, they should come to my club, or should come into the library at lunch, or this is now a thing they can go elect to do if you have an elective class if you're in middle school.
Yeah, so like the class that I went to this semester, we started with code.org, and the moment I told them about code.org, they were like, oh, I knew about this, the hour of code, so like it's a great like beginner point for a lot of students. And yeah, this is what you were talking about the different themes.
Yeah, and also code.org offers like a lot of free professional development like workshops for teachers. I think you can go next. Yeah. So you can like go onto their website. It looks like you can like contact the facilitator. I think they were actually supposed to have a conference here in Connecticut, but it got canceled because it's snowing. It was actually the same time as our event. But yeah, so they have like a lot of free resources for teachers, which is great.
Yeah. Oh.
So everything you need to find out about the code.org website, it might be a bit like confusing to navigate, but yeah, just like make sure to check out all the tags.
Oh, and also one last thing to mention, I think I skipped through the videos, but when you go to the activities, they usually begin with a video, so like that might be helpful for like maybe the teacher to review before like teaching the concept to the students, or even have the students watch the videos themselves. Yeah.
Although I think we found that when we were in some classrooms, like they didn't interact as much with the videos.
Oh yeah, they would just like close it out.
Yeah.
Yeah.
It's actually a really big challenge. The students frequently will skip the video, but the video contains instruction.
Yeah.
Contains really crucial. Here's this new concept you need to understand to solve a puzzle. They don't watch.
Yeah.
So sometimes you just have to say, watch the video.
Yeah.
Or just reenact it for them.
Kind of like how they don't read the instructions.
Yeah.
That, at least, though, once they X out the video, it's hard for them to relaunch it. But the instructions are sitting there right in front of them. So
they can go back.
even if they X'd out the instructions, they're still sitting right there. So if they're getting stuck, they can, okay, fine, I'll read the instructions.
So do you guys have any questions for us?
Is it really obvious how to get to that maze thing that you...
Yeah, I think so. I can do it right now. If I go to code.org, you make an account.
No, actually, I think you can just do it without making an account.
I just
Yeah.
want to learn how to do it.
Oh, okay.
All the stuff
Learn button.
Okay.
Oh, okay.
Yeah. And then you have your
So
different
those are
grades.
full courses, those are just the short ones.
Our code
And
is
the
right here.
mazes are the last ones for our code. You can just like start doing it.
They redesign this page fairly frequently.
So
they'll
yeah, so you have
move
your
around
videos.
things, but it'll always be easy to find them. One thing Code.org also tries to do is they think about representation a lot. So in those videos, they're working very hard to try to find just very different people.
Yeah.
Gender, race and ethnicity, what different kinds of jobs people have.
Mm-hmm.
So those videos are actually pretty great.
I agree.
I think we are at time.
Yeah,
and
it's time for lunch.
Yeah, I think it's lunch.
Yeah. But thank you so much for coming to our